Hello friends, our lesson today is about matter and its characteristics, or we can say that matter and its properties, because characteristics means properties. But before we study the properties of matter, let us understand well what's meant by matter. What's matter? So look here with me. As you can see here, we have two tables. Large table and small table. Both of them are made up of wood. But let me ask you a question. Which one of them contains much more amount of wood? Yes, the large table contains more amount of wood. And the small table contains less amount of wood. This is exactly what's meant in science by mass. So instead of I say the large table contains much more amount of I can say simply large table has more mass. Mass. So once I say mass, you understand that the amount of wood of the large table is more. Let's read the definition of mass. Mass is the amount of matter. This matter could be wood, plastic, iron, paper, whatever. So the amount of matter the body contains is the mass of this object. So we said that the amount of wood that the large table contains is larger. It means that the mass of the large table is larger. The small table, the amount of wood that the small table contains is less. It means that the mass of the small table is less. So again, matter here is like wood. The body contains here, this body could be the table. Clear? Now another question. After we understood what's meant by mass, and mass means the amount of matter in an object, I have another question here. Which table of them takes more space from this white slide, or from this white space? Which table of them takes more space? The large table or the small table? The large table. Right. Large table takes more space. Look, it takes more space from the slide. But this table, no, it takes just a small space from the slide. Again, in science, we can use a scientific term instead of all of this sentence. This is called volume. So instead of I say the large table takes more space from the slide or from this white space, I can say simply large table has more volume. So let's read the definition. Volume is the space that's occupied by the body. Space that's occupied by the body. Body could be table, book, pen, you, chair, and so on. Now let's read again the two definitions. Mass, the amount of matter the body contains. And the measuring unit of this mass could be with gram or kilogram. Volume is the space that's occupied by the body. And the measuring unit of volume could be centimeter cubic or liter. We have many other measuring units, but let's say them now.
Now, after we understood what's meant by mass and volume, let me say that everything around you, everything that could has mass and volume, this exactly what's meant by matter. Because matter is everything that has mass and volume. But teacher, what about this green ball? It's so small. Is it matter? Of course, yes. It's small, but it has small mass and small volume. And because it has mass and volume, it's matter. And so on. Miss, what about the sand? The sand, this is very small particles. No problem, but this small particle has mass and takes space or has volume. Therefore, the sand also is matter. I can say that everything around you is matter. Now we finished what's meant by matter. And I think now you understood well what's matter. Now let's study the properties of matter, or how can we differentiate by different matter. Look here with me. We have two ways by which we can differentiate between matter: physical properties and chemical properties. When I say physical, I mean the shape or the form, the out form of the matter. But when I say chemical, I mean the reaction that takes place with the matter. Let's first study the physical properties. And there are 7 points we will take in these properties. Let's start with the first one. Here, the first point in the physical properties. If I asked you to differentiate, or I asked you, how could you know that the ring is gold or silver? What will you say? Yes, the gold ring has yellow color, while silver ring has white color. So now you differentiate between the rings by what? Very good, by the color. And also look here for this example. Here I have sugar and I have salt. Now, can you differentiate between them by using color? Of course no, because both of them are white. So how can you differentiate between them? By taste. Very well. Number 3, look here. This is perfume and this is vinegar. How can you differentiate between them? Can you test them? Of course no. From the color? No too. Both of them are yellow. How could I? Smell. Smell. So this is the first physical property by which I can differentiate between matter: color, taste, and smell. Color, taste, and smell. Let's see the second point. And it's really so important. Focus with me. Here, as you can see, I have 2 cubes. One of them is made up of wood, while the other one made up of iron. If I asked you here, which one of them takes more space from the slide? Which one of them has more volume? What will you say? Both of them have the same space. Both of them take the same space from the whiteboard. So they are equal in volume. But if I asked you, which one of them has more mass? Which one of them is heavier? The cube which is made up from wood, or that one that is made up from iron? Iron! The mass of this iron cube is greater than the wood one. So look here, as you can see in this example, they have equal volume but different mass. This thing happens with all matter around you. There is no 2 different matter have the same mass and volume at the same time. Never. If they have the same volume, they must have different mass. If they have same mass, they must have different volume. So no two matter have the same volume and mass at the same time. What did this say, Miss? Mass and volume. The relation between mass and volume, it's called what? It's called density. When I tell you that there is no two matter have the same volume and mass, I mean that there is no two matter have the same density. So instead of I say no two objects have the same mass and the same volume, I say no two objects have the same density. So I mean that density is give you the relation between mass and volume, so that we can define density. As you can see here, it is the mass of unit volume. What does it mean, teacher? It means that if I have 1 centimeter cubic of iron and I get its mass, now it is the density of the iron. If I have 1 centimeter cubic of wood and I get its mass, now I have the density of the wood. So the mass of unit volume is the density. From the definition of density, we can conclude the law, the mathematical law, by which we can find or calculate the density of any matter. Tell me, from the definition of density, what are the factors that affect the density? 2 factors, mass and volume. Therefore, the density will equal mass over volume. The measuring unit of mass could be gram, kilogram, ton, whatever. And the measuring unit of volume could be centimeter cubic, meter cubic, liter, and so on. There are many measuring units. Now we understood what's meant by density because it's so important. Let us read the definition again. Density is the mass of unit volume of substance. And remember, no two matter have the same density. Now look here. Let's answer or solve this problem. A piece of iron has a volume of 10 centimeter cubic and a mass of 78 grams. Find the density. Before I answer any problem, the first step that you have to make is that you have to write the law that you will use. So the law that I will use here is the law of density. We said density equal what? Good. Density equal mass over volume. Now, after you wrote the law, you can compensate or you can put the number. What do I have? I have mass and I have volume. What do I need? I need density. So I put the number. Mass, I have mass equal 78. I have volume equal 10. Division give me 7.8 gram over centimeter cubic. So easy. Let's see another. What's meant by? Once I see a question like what's meant by, I have 2 options, no more. As I said before, and I will always say the same thing. Once I see a question of what's meant by, I have to think about 2 things. Maybe he gave you the scientific term, so he needs the definition, or gave you the definition, so he needs the scientific term. Now look in this question, for example. What's meant by the density of water is 1 gram over centimeter cubic. Density. He gave you the scientific term. So he needs definition. What is the definition of density? Yeah, I will say that the mass of unit volume, like 1 centimeter cubic, because he gave it to you here. So I will say the mass of 1 centimeter cubic of water equal 1 gram. The mass of 1 centimeter cubic of water equal 1 gram or as 1 gram. I have an important note here. This is what I told you before, but I will repeat it again. No two substances have the same density. No, never. Here in these two cubes, means they have the same volume. The iron and the wood, they take the same space, they have the same volume, but they don't have the same mass. Okay, I will take a larger piece of wood, so they will have, now they have the same mass. Okay, no problem, they have the same mass now, but they have different volume. So never, never, never you have two substances have the same volume and mass at the same time, which means never have the same density. I have here an experiment by which we can make it more clear for you that there is no two substances have the same density, and by the same way how can we apply the density in our life. Look here. I will bring, as you can see here, tank of water, and I will bring to a piece of wood, an iron nail, an ice cube, a piece of cork, a piece of wax, drop of oil. I will put all of these 6 things in the water and see what happens. What will stay in the surface of water and what will go down. So look here with me. As you can see here, the wood, the cork, the oil, and the ice cube, all of them stays on the surface, but the nail and wax go down. Why do you think that's happened? Because of the density. How may I explain? I said there is no two things have the same density. Maybe this density of the other things bigger or larger, or maybe smaller. And it happened here. The wood, the cork, the oil, and the ice cube have less density than water. They have less density, less mass per unit volume, so that the water can carry them and make them on its surface. But in case of nail and wax, they have larger density than the water. They have more mass per unit volume than water. So the water cannot make them on its surface. They faster go down and stay on the bottom of the water. So again, things that stays on the surface has lower density than water. So water can carry them. But things that go down, they have higher density than water, so that water cannot carry them on its surface. Understood? Let's see other applications on density in our life. As you can see here, number 1, the water cannot be used to put out petrol fire. Why? Why I can't use water to put out petrol fire? Look here. This man is trying to close a fire by using water, and this fire is made up from petrol. Look what happened. When he put the water on the fire that's made from petrol, you think it will close out or put out? Actually, no. The fire become bigger and bigger and bigger, and he never can put it off. As you can see here, he make more fire. So I think it's bad idea to put out petrol fire using water. So why I explain this phenomenon? What happened here? What happened here is that the density of petrol is less than water. So when you put water, the oil or the petrol goes on the surface on water and never go down. It goes on the surface, so the fire stays working. Look here the answer, because the density of petrol is less than water. So petrol floats on water surface, therefore doesn't put off the petrifier. Another example here. The balloon that filled with hydrogen or helium rise in air. Why I have to put hydrogen in the balloon? Why I don't just put my air, my mouth air on the balloon? Because the density of hydrogen and helium too is less than the air. Now we've finished two of the properties of matter, which is number 1, color, taste and smell, and number 2, density. Next video, inshallah, we'll continue the rest of the properties. Thank you so much, and if you have any question, leave it for me in the comments. See you in the next video. Bye bye.